Our goal in math this year is to get our students to think mathematically, not tell them what to think. And so our journey began with the number 1. Students were each given a blank hundreds chart and asked to color in all the multiples of 1. Quickly, rumblings of what is a multiple of 1 ran through the 2 classes. Some students had ideas, but few were 100% certain. Pulling the kids together, we posted the question on the board.
Students were invited to make conjectures, just as mathematicians would in the real world.
My conjecture is everything that you can multiply by 1. Everything you can multiply by 1.
Okay. Yep.
1, 11, 21, 31.
Okay. So anything that ends in a 1?
Yeah.
Okay.
Just anything that you could fit a 1 into.
Anything you can fit a 1 into.
You can tell by 1 to get it. Yeah.
Okay.
So practically everything. 1 word, everything.
Liam?
I'm thinking it is that you can, if you can multiply 1 by something to get that number, that's a multiple of 1.
Okay. You guys should be thinking about whether or not you agree. Okay, because that's the next task, is for you as a group to support or not support these various conjectures.
Oh, we have a lot of theories.
These must be mathematicians. Do you think mathematicians have lots of theories or conjectures?
Yeah.
Yeah. And does it take a hard work to figure out which ones are true?
Yeah.
Absolutely.
For our kinesthetic learners, we wanted them to be able to see and act out what multiples of 1 are. Alex is standing up here all by herself. Okay, can I make Alex into a group of 1?
No. Yeah.
He's here by himself. Can he be in a group of 1?
Yes.
How many people are up here? Okay, can I split these 2 people into groups of 1?
Yes.
Okay, split them into groups of 1. You done? Okay, split them apart.
Good job.
Okay,
So,
we're
Brianna,
back
how
to
many
that.
groups do you have now? 2 groups and how?
One person, I made them into a group of 1, so 1 was a multiple of 1. Then I had 2 people. Did I make them into groups of 1?
Yes.
So is 2 a multiple of 1?
Yes.
Then I had 3 people. Could I make them into groups of 1?
Yeah.
So is 3 a multiple of 1? Okay, so a giant clump of 50 kids. Could I split each of you into individual groups of 1?
Yes.
Looking back at the conjectures written on the board, students had the opportunity to vote on whether each one was completely false, partially true, or completely true. We continue to review each conjecture by either eliminating them altogether or modifying them to be completely true. This was accomplished by adding words such as whole, equal, and greater than 0. Afterwards, students were ready to move on to the number 2. Their conjectures became more complex and the discussions were richer. Students worked collaboratively as a whole group to determine the validity of each conjecture. This was accomplished by adding specific detail to each one to ensure that it was completely true. By the end, they had a much deeper understanding of what a multiple of 2 is.
So everyone's on the same page, I think, because no one put their hand up for completely true and no one put their hand up for partially true. So can I put an X on this one? Okay. This one's not true.
Students were also encouraged to make additional changes to the conjectures on their own.
Can you explain why you're doing it?
Students added multiples of 2 to their hundreds chart and made further discoveries such as what constitutes even and odd numbers. Each individual was then asked to write his or her own definition for the terms even and odd. Forming a partnership, students compared their individual definitions. Afterwards, they joined a group where they established a group definition that encompassed all of their ideas. In the end, we had an exhaustive list of plausible definitions. To further emphasize the understanding of these terms, students were introduced to a game using their fingers, similar to rock, paper, scissors, but where students were awarded a point depending on if they had chosen to be even or odd. If the sum of the total number of fingers was 5, the odd person would win. If the sum of the fingers was 4, the even person won. After playing, students were asked to share things they noticed about odd and even numbers. They determined that two odds added together would always result in an even sum, which is also true when adding two even numbers. Yet an odd and an even will always result in an odd number. These big ideas will further assist students as they make new conjectures about different multiples.
We wanted students to continue thinking in real-world terms about ways in which math is relevant, useful, exciting, and potentially life-saving. To refresh their excitement and wonder about math, we showed students a clip from Apollo 13 in which math skills and peer reinforcement resulted in life-saving action.
Now, Jack, we need to proceed with steps 12 through 17 quickly. You're down to about 8 minutes remaining.
Okay. Fuel cell pumps off, O2 fans, tank 2 off.
Okay, Houston, check me. I've completed these Gibble conversions, but I need a double check of the arithmetic.
Yeah, you can go, Jim.
Okay, the roll cal angle is -2.
Motor module roll is 355.57. Pitch 1678. Correction, pitch 167 point. We'll end up out here.
Looks good, Fly.
All right.
Good here? He's good, Andy.
We asked students how this clip was linked to what we were doing in class. Cole found a connection to mathematical conjectures.
The group would check it out and support our ideas and see if they're correct and add on to it.
Okay, there were two kinds of communication because there's English language, which we all speak and which they spoke in that movie. And then there was another kind of language. Hamid?
Math language?
Yeah, so math and English. And they all understood it. Both.
Our next goal was to get students to think and communicate mathematically in terms of multiples. As a community of learners, we started looking at multiples of 2.
2 times 3 is? 6. 6. 2 times 4? 8.
We asked students to look for patterns and strategies that they could use to solidify their understanding of multiplication.
They're all even numbers.
Oh, do you see that before Chaim showed it? No. Yeah. Here, 18 minus 2.
Finally, we showed our students an instructional video by Mr. Numbers. He has an excellent way for students to see the patterns and explore numbers in a new way.
This is Mr. Numbers, and today we're going to play on number circles.
In small groups or individually, students were tasked with finding patterns and strategies within multiples of 3 to 9.
4.
So what multiples are you doing?
7 actually. Then 2. You go to 7. 7 plus 7 is 14. And then it's 21. And then it's 28. 5. Then 35. And then 42. And then 49. 2.
Okay, so do you need, what's the next after that?
Actually 57.
Is it 49?
And then 2. Oh yeah, 56.
Okay, so make the next line.
49, 56.
Okay, and then what?
7, 56, 63.
Okay,
Plus 6, that equals to 9, right? Then if you have 6 plus 9, that equals to 15, and you're increasing by 6.
each time?
Yeah.
Oh my goodness. And that's multiples of 3?
Yes. Like all
So what's
this
going
is
to come
a
next? Show me
multiple
what's
of 3.
next.
So like, practically what I'm doing now, I used to just add up the equations, right? But now all I do is just add 6 to the number that I just got.
Oh, okay.
Multiples of 8 in a circle or a triangle or in any shape. If you start at 0, you'll go to 8 and then to 16. And then if you just in the ones, it's 0, 8, 6, 4, 2, 0, 8, 6, 4, 2.
And how does it work on the circle here?
On circle, it's the same thing, and it makes a hexagon.
9. And then 9. And then 1, 46. 5. Actually, I got that one wrong. So 1, 2, 5. 1, 5, 8. 1, 5 is 11. So you keep going with the number opposite of it. So 10 boxes 1 and they.
But if you look here, you just have to add. So 1, 2, 2, 10. So you have 2 groups of 5 donuts.
1/2 happens is when, so this is going to be 3, 6, 9, and then the next one will be 9, then the next one will be 9, and then it's 5, that one's 5, 8, next one's 8, 1, next one's 1, 4, next one's 4.
Cool. That's sweet.
Students were incredibly engaged with the task of uncovering and identifying patterns within a set of multiples. Working collaboratively to build understanding has been a powerful learning experience for everyone.
We asked students to reflect on their mathematical understanding thus far. This is what they had to say. Aside from working through many concepts in the math curriculum, students have learned to question, rethink, reason, make connections, formulate conjectures to understand why theorems hold, and consider alternative strategies.
We are fostering a community of learners who work collaboratively, support one another, and communicate using the language of math. Through metacognition, students are learning to reflect, thereby solidifying their understanding and identifying areas in which to dig deeper.
As Marcel Proust once said, and we have since discovered for ourselves, the real voyage of discovery consists not in seeking new landscapes, but in having new eyes.